In this video, we will be doing two proofs, both with subtraction, one with segments and one with angles down here. So you can see what's the same, what's different. So first thing is AC is congruent to BC. So AC is congruent to BC. And then AD is congruent to EB. AD is congruent to EB. Now from there, you can see very plainly that if, let's say this is 10 and this is 3, and that's 10 and that's 3, if I cut off 3 from 10, I get 7 on both sides. It's easier to see with numbers, then you have to be able to do the general theorem. So here we go. AC is congruent to BC given, AD is congruent to EB given, done on the diagram. DC is congruent to EC, that's here. DC is congruent to EC because if congruent segments are subtracted from congruent segments, then the differences are congruent. You just want to repeat that about 5 times until you can say it plainly. Now we go to angles. Remember, this is a new proof down here. Given angle CAB is congruent to angle CBA. Angle CAB is congruent to angle CBA. Angle EAB is congruent to angle DBA. So angle EAB is congruent to angle DBA. Overlapping angles are very hard to see at first. One way of thinking about it is if this is 70 here, and if this is 70, and if this is 30, and this is 30, well, then we have 40 left here and 40 left there, so they are congruent. In general, you won't put numbers on them. You just need to make it so that the theorems are common sense. So here we go. Angle CAB is congruent to angle CBA, CAB, CBA. Angle EAB is congruent to angle DBA, EAB, DBA. So angle CAE is congruent to angle CBD. What's left here is congruent to what's left there. The reason being, if congruent angles are subtracted from congruent angles, then the differences are congruent. Again, the way to get the theorem in your head is just to say it about 5 times until you can say it clearly and plainly without looking. Then turn your paper over, put the diagram here, and go through the thought process on each one again.